In this lesson, we will review how we can mathematically describe straight lines. When a plot of y versus x is a straight line, we say that y is a linear function of x. Symbolically, we can summarize the relationship between x and y by writing the equation y is equal to mx plus b. In this equation, the letters m and b are constants. The constant m is called the slope of the line, and the constant b is called the y-intercept. The y-intercept is the value of y where the line crosses the y-axis. It's the value of y when x is 0. Let's look at some examples. For which of these is a plot of y versus x a straight line? Let's take a look at choice A. This describes a linear relationship. We can see that the coefficient of x is 2, which is a constant. This means that m is equal to 2. Subtracting 3 means adding negative 3. This means that b is equal to negative 3. In other words, in this case, y is 2 times x plus negative 3. Let's take a look at choice B. This is also a linear relationship. Why? We can see that x is divided by 2. Dividing by 2 is the same thing as multiplying by 1/2. So we are multiplying x by 1/2, which is a constant. Therefore, m is equal to 1/2. But we're not adding anything to x over 2. Well, that's the same thing as adding 0. So b is equal to 0. In other words, in this case, y is 1/2 times x plus 0. Let's take a look at choice C. The relationship between x and y here is not linear. If we plot y versus x, we don't get a straight line. We get a curve. Here we have x squared, not just x. Finally, let's take a look at choice D. We don't see an x in the expression, but this is what we get if m is 0. 0 times x is equal to 0, and we don't have to write it. In other words, the equation y equals 4 is essentially the same as the equation y equals 0 times x plus 4. So in this case, m is 0 and b is 4. What this equation is basically saying is that regardless of what x is, y is equal to 4. This equation describes a horizontal line. A zero slope implies a horizontal line. The equation y equals mx plus b is called the slope-to-intercept form of the equation of a line. The equation can also be written in the form a times x plus b times y equals c. Here, a, b, and c are constants. This is called the standard form of the equation. So if we see an equation like this, we know that a plot of y versus x is a straight line. But what would be the slope and intercept of the line? We can figure it out from the values of a, b, and c. Starting with ax plus by equals c. We subtract ax from both sides. This removes ax from the left-hand side and leaves b times y. And on the right-hand side, we get minus ax plus c. Dividing both sides of the resulting equation by b, we get y equals negative a over b times x plus c over b. We can see that the slope, which is the coefficient of x, is negative a over b. And the y-intercept, little b, is c over big B. Let's do an example. What are the slope and y-intercept of a line represented by the equation 3x plus 2y equals 6? Here we can see that a is 3, b is 2, and c is 6. Therefore, the slope m, which is negative a over b, is negative 3 over 2, and the y-intercept, little b, which is c over b, is 6 over 2 or 3. The slope-to-intercept form of the equation is y equals negative 3 over 2 times x plus 3. The equation of a line is sometimes written as y minus y1 equals m times x minus x1, where x1, y1 are the x and y coordinates of a point that's on the line, and m is the slope. Since this equation is based on the location of a point and the slope, it is called the point-slope form of the equation. Recall that the slope-to-intercept form of the equation, y is equal to mx plus b, is also a valid way of describing the line. We already know the slope m. How do we determine the y-intercept b? All we have to do is substitute x1 for x and y1 for y, and we get y1 equals mx1 plus b. Everything in this equation is known except b, so we can solve for b, and we get b is equal to y1 minus m times x1. Suppose the equation of a line is given by y minus 1 equals 3 times x plus 2. What is the y-intercept b? The equation given here looks like the point-slope form y minus y1 equals m times x minus x1. We can easily identify y1 as 1, and the slope m as 3, and x1 as negative 2. Why negative 2? Note that we should match up x plus 2 and x minus x1. Remember that x plus 2 is x minus negative 2, so x1 is negative 2. Finally, figuring out the y-intercept b is a simple matter of calculating y1 minus m times x1. Plugging in the numbers, we get b is equal to 7. The slope-intercept form of the equation is y equals 3x plus 7. The slope is 3, and the y-intercept is 7. If we know the slope and y-intercept of a line, how do we graph it? 2 points define a line, so all we have to do is mark any 2 points that satisfy the equation y equals mx plus b. Then, use a straight edge to draw a line through the 2 points. Here's an example. Suppose we want to graph y equals 3x plus 1. Here's the Cartesian coordinate system with 2 points that satisfy the equation. It's usually convenient to choose x to be 0 for one of the points. That's what we did here for point number 1. x1 is 0. Then we calculate y for point number 1 as 3 times 0 plus 1, or 1. Here's the point number 1 marked on the Cartesian grid. It's at x equals 0 and y equals 1. Notice that it is on the y-axis since x is equal to 0. It's where we expect the line to cross the y-axis as expected, since our y-intercept b is 1. For the second point shown on this grid, the x value we chose is 1. The corresponding y value is 3 times 1 plus 1, which is 4. Here's point number 2 marked on the grid. Here, x is 1 and y is 4. Finally, we draw a line through the 2 points we chose. Given a line, we can determine the slope m by using the formula y2 minus y1 divided by x2 minus x1, where x1, y1, and x2, y2 are the x and y coordinates of any 2 points on the line. Note that y2 minus y1 is just the difference in the y coordinates of the 2 points, or the change in the value of y when we go from one point to another. It is customary to represent difference or changes in value using the Greek letter delta. So, y2 minus y1 is delta y. Similarly, x2 minus x1 is just the difference in the x coordinates of the 2 points, and we can refer to it as delta x. Since slope is just the ratio of the change in y to the change in x, we can think of the slope as the corresponding change in y if we change x by 1. Note that when delta x is 1, m is just equal to delta y. Since the y-coordinate refers to vertical coordinates, delta y is often referred to as the rise, and delta x, the change in horizontal coordinates, is referred to as the run. The slope of a line is often defined as rise over run. What is the slope of the line shown here? To determine the slope, we pick any 2 points. Let's pick this one, and call this point number 1. So x1 is 0 and y1 is 1. For the other point, let's pick this one and call this point number 2. So x2 is 2 and y2 is 5. Plugging in the coordinates in our formula for slope, we get slope m is equal to y2 minus y1, which is 5 minus 1, or 4, divided by x2 minus x1, which is 2 minus 0, or 2. So the slope is 4 divided by 2, which is equal to 2. Note that regardless of which 2 points we pick, we get the same slope. In other words, we say that the slope of a line is constant. The slope of a line can be positive 0 or negative. Which of these lines do you think has a negative slope? Remember that slope is delta y over delta x, or rise over run. And for a straight line, the slope is constant. So we can pick any 2 points on the line to determine its slope. Let's examine the green line. Let's pick this point at point number 1, and this point as point number 2. We can see that going from point number 1 to point number 2 is going from left to right, from a smaller x value to a larger x value. So delta x, the run, is positive. We can also see that going from point number 1 to point number 2 is going down, from a higher y value to a smaller y value. So delta y is negative. We could say that the value of y did not rise, instead it fell. So the value of the rise is negative. So in this case, the slope, which is equal to a negative delta y divided by a positive delta x, is negative. A good way to quickly recognize a negative slope is to imagine yourself running on the line. If you run from left to right and you end up at a lower elevation, then the slope is negative. Put another way, we could say that a negative slope means that the left to right direction is downhill. What do you think is the slope of the red line? It should be easy to figure out that the slope for the red line is positive. A good way to remember is to think of a positive slope as an uphill climb when you go from left to right. What about the yellow line? The slope in this case is 0. Why? As you go from left to right, the y value does not change. Delta y is 0 regardless of delta x. A horizontal line has a 0 slope. What about a vertical line? For a vertical line, we say that the slope is undefined. For a vertical line, we cannot have a run that is non-zero. If the run, or delta x, is 0, we would be dividing by 0 to calculate the slope. What is the significance of the magnitude of the slope? Let's examine the two lines shown here. Which one do you think has a bigger slope? Recall that slope is equal to rise over run. A good strategy to answer this question is to compare the rise of the two lines for the same run. The line that rises more for the same run has a bigger slope. To save time, let's examine the points where the lines intersect. Let's see what happens for this much run. We can see that the red line rises by this much, and the green line rises by this much. Therefore, the green line has a bigger slope. All we have to do to compare slopes is to compare the steepness of the lines. The steeper line has a larger slope. What if the slope is negative? It should be easy to see that a steeper downhill line would have a more negative slope. More negative means bigger absolute value. What happens to the value of a slope as a line becomes more and more vertical? We can think of the slope of a vertical line as the upper limit for the number we use to describe the steepness of a line. So a slope approaching positive infinity is approaching the vertical limit, but a slope approaching negative infinity is also approaching the vertical limit. That's why we say that the slope of a vertical line is undefined.